The second rule we are going to look at is the quotient rule. So let's look at the quotient rule. Again, we have two conditions. And my first condition, it must be division. And I actually prefer to write my division in the form of A over B, in other words, a fractional form. The second condition is it must have the same base. Okay, if those two conditions are met, then what happens? Okay, so we're going to then do, what are we going to do? Okay, first of all, number one, keep the base. And number two, subtract the exponents. Now, when we subtract these exponents, we can either subtract numerator exponent minus denominator exponent, or we can do the subtraction wherever the larger exponent is. Okay, so let's look at that. Let's do an example of that particular rule. Okay, so we have 3 to the third divided by 3 to the second power. Okay, so first of all, is it division? Yes. Is my base the same? Yes, they're both the same base. So now we're looking at doing the actual application of it. So I keep my base, I do my subtraction, numerator minus the denominator, which equals 3 to the first power, which is simply 3. Okay, again, why is this true? This is true because 3 to the third is 3 times 3 times 3. 3 to the second is 3 times 3. Thus, they eliminate each other, and I end up with 3 divided by 3 is 1, 3 divided by 3 is 1, and I have a 3. So 1 times 1 times 3 is 3. 1 times 1 on the denominator is also 1, and I end up with 3 over 1, which is 3. So you see, the reason is always based in the definition of exponents, okay? So now, let us look at another example. What if I had 3 to the second over 3 to the third? Now, what would happen if I did that one? The rule says I can either do my subtraction as the numerator exponent minus the denominator exponent, or I can choose a different way. So what might be another way I could look at this? Well, I could look at this as doing my subtraction here in the denominator where my exponent is the larger of the two. So when I'm doing that, I'm actually dividing both top and bottom by 3 to the second power, which then this makes 1 on top, and I'm left with 3 to the 3 minus 2, which is then going to equal 1 over 3 to the first power, which is just 1 over 3. And again, we can do this by using our definition. 3 to the second is 3 times 3. 3 to the third is 3 times 3 times 3. Thus, 3 divided by 3 is 1. 3 divided by 3 is 1, and I have 1 times 1 gives me 1 in my numerator, and 1 times 1 times 3 gives me 3 in my denominator. So you see, it makes sense to do it. And we could do numerator minus denominator, but we would end up with a negative exponent. And I haven't showed you yet what to do with that, but we will in a little bit. So here is the basic foundation of the division rule, okay, of the quotient rule. So now let's look at another example. Let's look at 6x to the third y to the fifth divided by 2x to the second y to the second. Okay, so now I've got a 6 divided by 2, which is equal to 3, and that's in the numerator. Notice my larger exponents are all in the numerator. My smaller ones are in the denominator. So I'm just going to do all of it with my x to the 3 minus 2, my y to the 5 minus 2, which is going to give me 3 times x times y to the third power. Pretty straightforward. Remember, it must be division, it must have the same base, and you keep the base and subtract the exponents. And that is, in essence, the quotient rule. Now let's make one problem a little more complex. Let's do a combination of the two rules. 2x to the fourth, y to the fifth, times 3x to the second, y to the ninth, divided by 6x to the fifth, y to the second, okay? So, first of all, let's do the numerator where we have the multiplication. And this is going to equal 2 times 3, which is 6. X to the fourth times x squared, here's your same base, with a x to the 4 plus 2, which is x to the 6th power, and y is the same base, and I have the 5th and the 9th, so I have y to the 14th power, because 9 plus 5 is equal to 14. Now, this is going to be divided by 6x to the 5th, y to the second. 6 divided by 6 is 1. Notice, my numerator is larger than the denominator, so therefore it's going to be 6 minus 5 and 14 minus 2, which is going to give me x to the first power, or just x, and y to the 12th power. So you see, we can combine the rules too and have them become a little more developed and a little more complex by combining both a product rule and a quotient rule in the same problem.